Alright, welcome to our Unit 6 Day 5 video. This video is going to be a little bit different. You are going to take some notes on your own notebook paper. We're not going to use as many examples in the video. We will do our examples in class where you can actually work on graph paper that I'll provide. But rather than try and make you do all these without really having graph paper to use, I'm going to have you jot down some notes about what these different topics are, and we will do the examples in class. So it's going to look a little bit different. You won't see me writing down as much like this. The screen will look a little bit different here in a minute. But you do need to set up your note paper like this. You need to title it Unit 6, Day 5, Transformations. There's three kinds of transformations we're going to look at: translations, reflections, and rotations. So as you go through, I want you to title each one of these when you see the information I present with the translation, and then write your notes about transformations there. I'll kind of tell you what to write down as we get there. And then when we're done, we'll go on to reflections. You'll write those notes there. And then when you're done with that, you'll have room for rotations. So it may take more space than what you see here. So your note paper should look a little bit like this with some writing in these spots when we're done, but it's going to look a little bit different as far as what you see in the video. Okay, so we're going to go ahead and start by looking at our transformations. Alright, so you'll see that we are working with transformations. You'll see this looks a little bit different. You won't see my hand writing things down, but you will see the cursor moving around, so pay attention to that, because it'll point to some things I want you to write down. We are looking at translations, reflections, and rotations. So let's take a look at our first set of information. Now, this is the part you don't have to copy down. This is just an example to follow along with. This is what I want you to write down. This is your definition of what a translation or a slide is. It's moving a figure to a new location by sliding it left or right and up and down. And in a transformation, every point on our new image is going to be the same distance from its original corresponding point in what we call the pre-image. What you start with is called the pre-image. Okay? And so when we translate this, we usually follow a translation rule written kind of like this, where they tell you what to change x by and what to change y by. You'll always be either adding or subtracting to x and adding or subtracting to y to get new coordinates. So if we follow this rule, we can create a table to help see our new set of coordinates. Okay? And we're going to do that, and I'm going to show you how to write all this out. You don't have to write this part down unless you just want to. Any of these extra notes over here in white that you want to take, you can. But if we take a look at our original figure, which is a triangle, we would mark those coordinates out. Okay, V, N, and P have these coordinates in the coordinate plane. Remember, the first number is your x, second number is your y. We're going to take every x coordinate and add 2, every y coordinate and add 1, according to this translation rule. Okay, so we're going to use that rule to find and graph our translated points. And so we would call this original point V, and now is a new point called V prime. So make sure you're listening to this. This little looks like an apostrophe after the V is called prime notation. So V changes into V prime at the point 0, 3. And N changes into N prime at the point -1, 3. And P changes into P prime at 0, 4, because we've added 2 to each of these x's, and we've added 1 to each of these y's. I want you to look at what happens when I do that. To go from V, when I add 2 to the x, I go from -2 over to 0. When I add 1 to the y, I go up 1 from 2 to 3. So this is a right 2, up 1 rule. And so if you notice the directions from this, we don't have to make the table. You could just see that you're going to go to the right 2 and up 1 from every one of these. So we take P, go to the right 2, up 1, V to the right 2, up 1, and N goes to the right 2, up 1, and we would get a new figure. Okay. The next transformation we're going to talk about is a reflection. A reflection is a mirror image as seen across a line. Okay, and so if we want to reflect this, they're always going to tell you what line to reflect it across. A lot of times that'll be an axis. They might say reflect this across the y-axis or the x-axis. But in this case, they want you to reflect it across the line x equals -1. This is a vertical line, so I'm going to sketch that so you see it. This is our reflection line. And so we're going to reflect every point here across to the opposite side. And so there's a rule that it follows, and I'll help you see that in just a minute. But all you're doing is picking each point up and moving it to the exact opposite side of that vertical line. So this point C here is going to just go over here and become C prime. This point U would go all the way. It's 3 to the right of that line, so it's going to go and be 3 to the left of that line, right there. And then A is actually going to go from left over to right now. It's going to reflect this way because the line goes through your figure. And then D reflects back over here. So it really is just picking up each point and moving it to the exact opposite side, however many units it is from the line on one side. The new point, or prime point, is that many units on the other side. Okay. Notice if my reflection line is vertical, every reflection happens horizontally. I don't move it up or down, I just move it left and right. If I were to reflect across a horizontal line, every reflection would be vertical. I would move it up and down and not left and right. Okay, because we're just going across that line at a 90-degree angle. Okay. Now you can also reflect across different lines. In this case, they tell you to reflect across the line y equals negative x, which would be this line. And so we're going to move every point exactly opposite according to this line, and that's a little bit trickier to do. And so we're going to look at a rule for how to do that a little bit later. That leads us to rotation. Okay, rotation, turning a figure clockwise or counterclockwise around a given point is what I want you to write down under rotation. Okay, you're turning. Rotating means to turn. And notice that we can move it either clockwise or counterclockwise. Okay, counterclockwise goes this way, if you're watching the cursor, and clockwise goes the other way. It's like the hands of a clock move. Okay, and we usually, almost always, will revolve this or rotate it around a given point, which we'll call the origin. So on the graphs, we're rotating everything around the origin. Even though it could be done differently, we're not going to get into that this time. Okay, so you'll notice that these pictures, these arrows, are all rotated. If I started with this one, I could rotate in 90-degree increments and get the other three. And most of our rotations will be in 90-degree increments. Okay, so a counterclockwise goes around and to the left like this. Okay, so you can maybe even draw an arrow like this in your notes, that this is counterclockwise in this direction. So if I'm going to rotate 90 degrees counterclockwise around the origin, okay, the easiest way to do this is going to come up in a minute. But one way you could do it, this first way is not the easiest. One way is to make a table and follow this rule. Okay. If I were to rotate my paper 90 degrees clockwise, or sorry, counterclockwise, CC-wise is counterclockwise, you get a new set of points. Okay. If you actually rotate this to where this axis is now up and down, U is up here, F is over here, and E is up here. And so we get these new points. Well, those are the new coordinates. And then you can turn your paper back right ways up and just plot these points, and that takes care of that rotation. And what you notice is we followed this rule. To rotate 90 degrees counterclockwise, the X and Y switch places, and we make the Y its opposite, or negative. Okay? So 4, 0 becomes 0, 4. Now, negative 0 is just 0. That's the only one that doesn't really change because it's on an axis. But 2, negative 1 becomes positive 1, 2. 3, negative 4 becomes positive 4, 3. And we'll do some more of these in class. This is just an introduction. Now, if I rotate 90 degrees clockwise, it's going to be a little bit different. And again, we're going to start. You can make a table when you're doing these problems. But we can start by rotating our paper 90 degrees. And this time, we'll go clockwise. So again, maybe draw an arrow and write clockwise like this on your notes so you know which direction that is. And if I rotate my paper 90 degrees clockwise, I can write down the new coordinates. And this helps you see what that rule is. To go a 90 degrees clockwise rotation, we would exchange X and Y, switch the X and Y coordinates. 0, 5 becomes 5, 0. But then you're going to make the X coordinate a negative over here whenever you change it. So if it was a negative x coordinate here, it becomes positive 4 when you move it over. Negative 1 becomes positive 1 when you move it over. So it follows this rule for a 90 degrees clockwise rotation. To rotate 180 degrees around the origin, you'll notice 180 degrees, that's half of a circle. So 180 degrees clockwise is the exact same result as a 180 degrees counterclockwise. So it doesn't matter the direction you go. So we can make a table of our coordinates, and by rotating a full 180 degrees, we would just turn our paper 180 degrees. And again, when you have paper in class, we'll look at how to do this. And you get these coordinates. And so we notice what the rule is. The x's and y's don't actually change, but they exchange positive negative values. So we take the opposite of x and the opposite of y to get new coordinates. Negative 4 turns into positive 4. Positive 4 turns into negative 4. Negative 3 turns into positive 3. Positive 2 turns into negative 2. And so on with negative 5 to 5 and 3 to negative 3. Alright, and this concludes the notes that I have. There's not as much to do in the video. Again, any of this stuff in white over here you did not have to write down. So if you've been trying to keep up with that, I apologize, you're not supposed to. We're going to go back over some of these in class on paper so you can actually practice this in class next time we meet. But for now, writing down these rules, anything that's been over here, and I'll kind of go back through. Just a second. Let me click through a little more quickly to just remind you of things you should have written down. Okay, we talked about a translation. You need this writing in black. A reflection. You need this writing as well. A rotation. You need this writing as well. Okay, and I talked about drawing an arrow in this direction to call it counterclockwise so you know which direction that goes if you're having trouble. And then there is a rule for counterclockwise rotations of 90 degrees that we should probably follow. Okay, a 90-degree rotation counterclockwise follows this rule. So you need to write that down, but make sure you specify that it is for a 90-degree counterclockwise rotation. For a 90-degree clockwise rotation, we need this rule. Okay, so again, specify that for a 90 degrees clockwise rotation in this direction, we follow this rule. So make sure you write that down. And I'll give you these again during class. And for a 180 degree rotation, we came up with this rule. For a 180 degree rotation, and it doesn't matter if it's clockwise or counterclockwise, you'll end up with the same result, we get a negative x, negative y. And that concludes our notes for this video, so make sure you've jotted things down correctly. If you need to go back and re-watch any of this to copy it down, then you're welcome to. Otherwise, we will do some examples in class over transformations.